My name is Warren Cates. I am a senior project leader here in Houston at our Shell Research Lab. I am a senior project leader for industrial gear lubes.
How have wind turbine lubricants evolved over the last 10 years?
Previously, not too many properties had changed in lubricants in general. Just maybe over the last 20 years, things started really changing. The OEMs started getting more involved with lubricant, and they started looking at the lubricant as being a component. Okay, so in the last 10 years, maybe 12 years, the wind turbines really have started getting involved because, I mean, wind turbine applications are so difficult, right?
Yeah.
And so, you know, there are many things to lubricate. You know, so the gear lubricant, the main gear lubricant, has to not only lubricate the main gear set, but it's also got to lubricate the bearing, right? The main bearings, the high-speed bearings. You know, so in that application, you know, it's generally a lighter vis, you know, but they have to keep it very clean. Right. But in the gear set, it's a heavier fluid,
yeah,
right?
You've got these multi-stages. This one's moving
so
real
you've
fast.
Seen that,
this
right?
One's slower.
Absolutely, absolutely. And you know, but with that, so that means that you have to treat like a very thick fluid, like an ISO 320 fluid, like a 150. You know, so you have to be able to filter it. It's got to go through, you know, very fine filtration because of the offline filtration, and but that's a lot of it. So it's the lubricants now are seen more as components, you know, and also, you know, the wind turbines are in very remote areas, and especially in several parts of the world, right? Some of them are just in such cold areas, you know, so you have to have something that's able to get up to speed a little bit quicker so they can start producing electricity, get it to the grid faster.
Over the past 10 years, you've seen more turbines, you've seen more applications, like in the gearbox makeup, right? Like how it's brought up.
Absolutely. So one of the areas is yellow metal, influence of yellow metal, right? So there used to not be a whole lot of yellow metal. So we're talking like copper and zinc, you know, bronze type applications, and especially in the bearings, right? So when you do that, you know, you have to make sure that you're not hurting the yellow metal any, whether it's leaching copper or zinc, right? And there's different ways that you can do that. But you know, but the OEMs really, when we started out with this product, we went to talk to the OEMs, went to talk to all the major OEMs, and they were like, you know, what are your top 5? And in fact, we came away with 10 items. Filtration was one, cold temperature was one, and yellow metal protection was one as well.
Yeah, those are some, okay, so filtration, yellow metal, and temperature.
Cold temperature.
Cold temperature.
So seal compatibility is another thing, right? So so you probably have a lot of experience with seals. So, you know, changing the seals out in the applications. But seal compatibility has become a very high profile part of the testing, and in fact that's one of the harder tests to come across.
It's like how many elements can you put into the system, and then each element will change the outcome, right? And I think that's
absolutely. So, you know, if you think about
that's why you have so many tests going.
Right?
I mean, they have a ridiculous amount of tests going. It's a lot, and I think each one is going over, okay, what happens when we add this in, and what happens when we add this, or take away this, or it's interesting that you can collect all that data.
Back 30 years ago, you used to have a box, you know, the size of this room, right, to be able to formulate in. And each time that they add a performance or a test, that box gets smaller and smaller and smaller. And it, depending on what the OEM is, that box could move anywhere 3D in that area.
Yeah.
You know, so to hit all the OEM specifications sometimes is a tough thing because, you know, you're right. You know, when you're adding more components, more testing, more performance parameters, it just gets more difficult.
I think that's the highlight is the performance parameters set by the OEM and then the expectation from the customer. Expectations in wind are a lot higher right now for lubricants to perform longer, better, you know, that kind of thing. So, and you got to take all those elements.
Yeah. So Neil, that's a good point. So even with the oil life of a lubricant, you know, so if you're just looking at a mineral oil product, you know, generally maybe 3 years in a wind turbine. You know,
say like a hydraulic fluid.
Right. you know, but when you go into, you know, when you go into something that costs $20 million or $25 million to set up, you want the best, right? You want something that's in there that's going to be durable. So they've gone from 3 years to 7 years to over 10 years.
How has Shell innovated in the wind space?
So we knew that filtration was going to be important, yellow metal was going to be important, long life was going to be important, you know, and so we developed, my goodness, and I showed you some testing. We developed several tests that prove our point in many different areas, and we did it more for development. But you know, the more that you do those kind of tests, the more confidence you have in a product and what the product can do, right? And so yeah, we had to be very, you know, we looked at filterability, we looked at just all sorts of things just to see what we could do to improve product performance. You know, and it's a balance when you do this, you know, because if you're having to balance seal compatibility, you know, low temperature properties, filterability, yellow metal compatibility, my goodness, you want to make sure that you test them and then you test them again, then you test them again, you know, and what you're doing is you're just creating that funnel, and what comes out of that end of that funnel is the product that you want.